Hi students, before starting the lesson, I would like to give one information. At the end of each video or in between the videos, I have given some illustrations or images. After finishing the lesson, you go through the illustrations and the images because it is useful to you to understand the mode of inheritance. Students, today I want to discuss about how far the colorblindness character inherited from the parents to the young ones or the offsprings. Now, colorblindness was first reported by Wilson, and the pedigree of colorblindness was reported by Horner. So, Wilson observed this colorblindness, and the pedigree chart was prepared by Horner about the colorblindness. So it is inherited as a recessive X-linked character. So want to know the inheritance of that character, we have to know the phenotype and genotype of both female and male, that is women and men. Now here I have given the chart. So phenotype and genotype. As per the female is concerned, they are either homozygous dominant or homozygous recessive or heterozygous dominant. See, people with a normal vision, they have the gene in the X chromosome, I indicated as plus. The superscript plus indicates the gene for the production of the pigment for the perception of the different colors. So the normal vision persons, they have actually the dominant gene or the dominant allele plus. The colorblind female, they have the recessive genes C. They have the recessive genes C. They are unable to produce either the red pigment or blue pigment or green pigment for the perception of these colors. So, but there is no colorblind female at present, because once this embryo is formed with a colorblind condition, the embryo is aborted. That's why we can say there is no colorblind female. But normally 0.4% of the females are affected. That means colorblind embryo is formed, but that will be aborted. Now the carry. The heterozygous individuals are called carriers because they carry the gene, what we call the C, recessive allele C, hence they are called carriers. The heterozygous individuals are called carriers. So they are normal but carry. They are normal but carry. They are not affected. Now coming back to the males, man. So nearly 8% of the male individuals are affected. The reason for that one I mentioned, the sex-linked or X-linked recessive character is inherited. That is through X chromosomes, and that too, the males have the genes only the X chromosome, not in the Y chromosome. So people with a normal vision, they have one plus gene and no corresponding allele in the Y chromosome. That's why they present minus. And in the case of colorblind individuals, they have a recessive gene. There is no corresponding allele in Y chromosome. As these individuals are hemizygous, they are mostly affected when compared to, that is the males, compared to the females, not male, that compared to the females. Now let's go for, so this is about the genotype. You have to remember these genotypes, then only we can find out how far the character will inherit. Now, I'll take the inheritance. First, I am taking a marriage, an illustration. That is, a marriage between a normal visioned woman and a colorblind man. A marriage between, that is, a normal visioned woman and a colorblind man. How far the character is inherited. I will represent that one. Now, I'll take, that is, normal female, a normal woman. So, I am taking normal female. And also, you see that one, colorblind male, colorblind male. This is a marriage. These are the parents. Okay, we have the parents. These are the parents. I am representing the parents in the form of P1. So the normal female, they have, this is the genotype. This is the genotype. And colorblind male, now they have a recessive gene and no corresponding allele in the white cross. This is about the genotype and the phenotype. Now what are the gametes produced? What are the gametes produced? Now here all the gametes are similar. All the gametes are similar. Here 50% of the gametes with X chromosome and 50% of the gametes with Y chromosomes, because that is the males produce two different types of gametes. Now suppose what is happening in the first generation or F1 generation. If this egg, now the gametes, these are all the eggs, is fertilized by the sperm having what is called C, the gene. So we'll get what is called actually an individual normal but carrier female. Normal but carrier. There is no expression of what is called actually the recessive gene because of the presence of dominant genes. Now, if this egg is fertilized by the sperm having Y chromosome, we have, that is what is called normal male. Normal male. Normal male. So normal carrier, that is what is called female. Or we can say the daughters. The daughters. And here we have the sons. Now as a character is transmitted in a zigzag manner, you see that one. Now the male received, I mentioned already, the X chromosome only from the female. So he received what is called actually the dominant allele. So all the sons are normal. Simply we can say, and similarly, as we see that one, the female receives X chromosomes both from just mother and father. See, that's why we have 1 plus 1C. These individuals are externally normal but carrier for the gene C. Again, you see, the character is transmitted from female to male. What is called the X with plus gene is transferred to the normal male. Transferred to the male. So, from female to male, then male to female. This is what is happening in crisscross inheritance. Again, we can remember, how can I remember this one? So, normally in a family, we can take, there is always a controversy between a father and a son. Or there is no compromise between a father and a son. A father is saying one thing, the son is doing another thing in a different way. So this is a clue, oral clue for understanding the problem. If father is colorblind, definitely you see that one son will be normal. Father is colorblind, son will be normal. You remember this one orally. This is a clue for namesake. I am telling it's not in all cases true. Don't take it in a different way. So when father is normal, the son would be colorblind. In another case, I am telling the example. So here father is colorblind, son is normal. If father is normal, definitely the son would be colorblind. This is for your remembrance. You just remember that one, just orally. So father colorblind, son normal. Father normal, son will be colorblind. We'll see the next example. So this is one. Now we are getting what is called a carrier female and a normal male. Suppose a marriage occurs between a carrier female. I am taking carrier female. I am taking this one, carrier female. To get what is called actually the F2 generation, the next generation, carrier female and then normal male. Carrier female and a normal male. female and normal male. Now this is carrier. I am taking this one. It's simply the same one. This is carrier. And this is normal male. We have plus the dominant gene. Now what is happening? Once you have mother is carrier, definitely the next generation, that is what we have in F2. Out of the 4, see, as it follows what is called Mendelian inheritance. And Mendelian inheritance, what we are getting in the F2 generation, the phenotype ratio 3:1. 3:1. That means 3 tall, 1 tall. Likewise here, if marriage occurs between carrier female and normal male, we have received in the F2 generation, it's the next generation, 3 normal vision and 1 color blind. Out of that, actually you have to consider that way. There is always having a chance of 50% chance of having either male or female in each pregnancy. So we have to consider there are 4 individuals in the F2 generation because 3:1 ratio, totally 4. Out of the 4, 3 normal and 1 color blind. That means I mentioned there is always 50% chance of having either male or female. So out of 4, you can take 2 will be male and 2 will be female. This is the one we have to remember that one. So in the previous marriage, that is between a normal woman and a colorblind man, we received all the sons and daughters normal. But the daughters are carrier and the sons are normal. All the daughters and sons are normal, but the daughters are carrier. Suppose if you have a marriage between a carrier female and normal male, once mother is carrier, he can say easily about the males. What are the nature? What are the natures of sons? Once mother is carrier, there is no doubt about it. The F2 generation, 50% of the males are normal and 50% of actually the males are colorblind. That is 1:1 ratio. So out of 4 individuals I mentioned already, generally speaking, based on sex, 2 females, 2 males. Out of the 2 males, 1 is normal, 1 is colorblind. It occurs when mother is carrier. The least bothered about the nature of father. Once the word carrier is given, once the mother is heterozygous, the only chance of males would be 50% normal, 50% colorblind. That is, 1 is normal, 1 is colorblind. What about the daughters? If the father is normal, once mother is carrier, it is fixed. If father is normal, in such marriages, no daughter is affected. All the daughters are normal, but 1 daughter is carrier. All the daughters are normal, actually, but 1 daughter is carrier. That is, we can say, out of the 2 females or the daughters, 1 is normal, another one is normal but carrier. You have 50-50 chance. So, what to just keep it in mind, how? So once carrier is given, he can say easily about the sons, 50% normal, 50% colorblind. Once father is normal, if mother is carrier, no daughters would be affected. No daughters would be affected. All the daughters are normal, but 1 daughter is carrier. So this is about what we have the 2 marriages. Now we have to go for some more illustrations. So we will take another illustration. That is a marriage between a colorblind woman and a normal man. Now colorblind female normally has 2 recessive genes, homozygous. The normal male has 1 dominant allele, that is plus. In the previous marriage we have already seen, in the first marriage, when father is colorblind, the son would be normal. Likewise here, father is normal, definitely the son will be colorblind. The opposite one, father normal, son colorblind. Now in this marriage, see, in the F1 generation, all the sons are colorblind and all the daughters are normal but carry. All the daughters are normal but carry. So this is the thing happened. So the character is transmitted or the gene is transmitted from what is called actually female to male and male to female. That's why it's called crisscross inheritance. I want to give another illustration regarding the inheritance of color blindness. Here, the marriage between a carrier woman and a colorblind man. As I mentioned in the previous case, once a mother is carrier, you look at mother want to know the sons. You look at mother to want to know the sons. If mother is carrier, definitely 50% of the sons are colorblind and 50% of the sons are normal. This is always true. This is the code. Remember that one. Mother carrier, 50% normal, 50% colorblind among the sons. Out of 2, 1 plus 1. Then, want to know daughters. You look at father. In the previous marriage, if father is normal, all the daughters will be normal. But in this case, father is colorblind. If father is colorblind, mother is carrier, definitely out of the 2 daughters, one is colorblind. Another one is normal but carrier. Okay? Look at father to know the daughters. Look at mother to know the sons. This is what is happening. Now in the previous instances, a marriage between there is a normal woman and a colorblind man. We are getting what is called all the males normal, carrier and normal male. So out of that one, carrier female and normal male, out of the 4, 75% of the individuals are normal. Refer the previous marriages. That is 2 daughters and 1 son is normal, and only 1 son is colorblind in the previous case. Now in these marriages, out of 4, 50% of the individuals are normal. There is 1 female, 1 that is male. 50% of the individuals are colorblind. There is 1 male, 1 female. So totally we can see out of the 4 individuals, 2 plus 2, that is male and female, there is 50% normal and 50% colorblind. Together I am telling about the male and female. So the ratio here we are getting what's called 1:1 ratio. There we are getting 3:1 ratio. Here we are getting 1:1 ratio. So this is when female is carrier and male is colorblind. Now here the female is carrier and male is normal, the first one. So this is the value showing how far the character is being inherited to their children. Okay, so based on this one, I would like to just concrete, that is in a summarized manner in the form of table of column, how far the characters are transmitted. Now I want to tell you one information. A woman, a son of a woman who carries the gene for color blindness always has 50% of her sons are colorblind. 50% of her sons are colorblind. A son of a woman who carries a gene for color blindness always has 50% of her sons colorblind. The daughter will not be colorblind unless her father is colorblind and mother is carrier for the disease. Daughter will not normally be colorblind unless her father is colorblind and mother is carrier. So, I will give the table of column a little while after. Students, now I will give the entire illustration in one table of column. The first marriage, second marriage, etc. When father is normal and mother is colorblind. Now in these cases, definitely son will be colorblind and all the daughters are normal but carry. This is one marriage. The second marriage, once again father is normal but mother is carrier. Once mother is carrier, definitely 50% of the sons will be normal, 50% colorblind. And once father is normal and mother is carrier, no chance of colorblind in the case of female. 50% of the daughters normal, 50% normal but carrier. The third instance, when father is colorblind and mother is normal, definitely know that one. Father colorblind, definitely son will be normal. And the daughters, normal but carrier. Again, in the fourth one, father is colorblind and mother is carrier. Once mother is carrier, I mentioned already, there is only one chance. 50% of the sons will be normal and 50% will be colorblind. And want to know the daughters in that instance. Once father is colorblind, there is a chance of 50% colorblindness and 50% normal but carrier among the females. Again, I mentioned here, once father is normal and mother is carrier, want to know the daughters, look at father. Father normal, mother carrier, then all the daughters normal. Then father colorblind, mother carrier, then 50% of the daughters would be colorblind. So this illustration or the tabular column shows how far the character is being transmitted from one generation to another generation by crisscross inheritance. Thank you.